Good morning. Thank you. So it's my pleasure to be here today, and I'm going to describe a bit of the journey of the Internet of Things in oil and gas. And in the next 30 minutes, I'm going to describe a little bit the clear and present issues that exist in oil and gas, and they are actually quite serious. And then also how some of the digital technologies can create a path forward. And what's exciting, I think, about the oil and gas industry is that this digitalization of their entire value chain is not something that's a nice to have. In some ways, it's an absolute requirement as this industry faces some significant challenges ahead of it. But I think you'll also come away impressed by the sheer range of innovation that's possible in a number of areas, some of them that you probably expect and many that you may not. So hopefully you'll be surprised and interested by some of the things that I have to share. So I'm going to start with the perfect storm, what's creating this reason for change. Then I'm going to talk about the threats and opportunities that exist thanks to technologies. And then across the entire upstream to downstream cycle, I'll describe all the different places where digitalization can help improve productivity, uptime, speed, and yield, and safety in oil and gas. And then I'm also going to draw some relationships to the IoT platform itself. What are the enabling technologies from a digital perspective that are being put into service? And then I'll share that through the light of some customer examples as well, where I'll show you exactly what they have done and the benefits that they've been able to derive from that. So let's go ahead and get started. And I call this a bit the perfect storm. So since 2014, because of the decline in the price of oil from about $100 a barrel to currently around $40 to $60 a barrel, revenues in the oil and gas industry have come down almost 40%. At the same time, cost savings in that industry have only improved by 9%, which leaves a 31-point delta. And this is why, for an industry that was always focused on maximizing production, there is now a very strong focus on productivity. And this is new. Secondly, the energy sector is unfortunately also the second most attacked industry when it comes to cybercrime. And in years past, cybercrime was annoying, distracting, harmful to the company being attacked, for sure. What's changed in the last couple of years is thanks to ransomware. Unfortunately, cybercrime does pay. They figured out an ROI. So now they are getting paid for attacking companies and holding your data hostage. Thirdly, the oil and gas industry is going through a tremendous generational challenge. For every 5 jobs in the oil and gas industry, they only get 1 applicant. In the next 10 years, half of their workforce is retiring. And part of the reason for that is, of course, they have a need for employees sitting on oil rigs, vessels, out-of-the-way locations, which is an extra burden that a lot of young work seekers don't want to undertake. So they're not really an employer of choice, unfortunately. And then lastly, the aging of the infrastructure. Half of the infrastructure deployed is more than 50 years old, and 80% of the unplanned downtime comes from outages due to this infrastructure. So being able to monitor and detect potential issues before they arise is paramount. And unfortunately, because of the drop in the price of oil, CapEx spending is going down. So that infrastructure is going to need to keep doing its job for even longer. In 2016, Bain & Company published research on the chemical industry and looked at all aspects of the value chain, from sourcing, R&D, production, sales and service, and distribution, and asked the question, where can digitalization disrupt or enhance this value chain? And as you can see from this slide, almost every aspect of the value chain is being touched by these various digital technologies, Internet of Things, big data, smart engineering, and you'll see some of those use cases in my presentation. In fact, just this week, we heard that Shell is thinking about adding electric vehicle charging to its gas stations as an example of an omni-channel approach, taking advantage of drivers that would go and transition away from oil towards electrical mobility. But if we look more broadly, one of the main trends that's coming now to the oil and gas industry, as well as other industries, in terms of the industrial Internet of Things, is a range of technology innovations which frankly started in the consumer space. And it used to be said that in the 1980s, if you wanted to work with the best technology, you went to work for the government, for the military. You had incredible breakthroughs in terms of microprocessors, software, computers. And then in the 1990s, if you wanted the best technology, you went to work for an enterprise. You had internet, desktop computers. But ever since 2000, the technology revolution has been led by consumers, whether it's virtual reality, blockchain technology, or other forms of mobility and connectivity. What's interesting about now, though, is every one of those technologies, although pioneered by consumers, is having a much bigger impact in the industrial space. In fact, if you walk around these halls, you will see mention of blockchain and augmented realities and all these technologies being used in real-life use cases. And that is also the case in terms of oil and gas. So now if we look at the value chain, the way to think about oil and gas, for those of you that are not familiar with the industry, is we refer to it as upstream, which is where the wells are, extracting the oil, going through the whole transportation, logistics value chain, and then finally ending up in refineries, being delivered to consumers at retail in the downstream side. So upstream, midstream, and downstream. And I'll go through this and explain a little bit where the different technologies play. The other thing to consider, though, is today, in this entire value chain, we are developing separate, isolated systems, control systems, electrical systems, telecommunication systems, alarms and information for operators, and these are designed in isolation. So when we're looking for that 31 points of productivity, you'll see that some of the opportunity lies in integrating these disparate systems. In particular, here's an example of a helicopter view of the oil and gas industry, starting with offshore oil rigs, pumping the oil to on-site. And in terms of the offshore, we can increasingly do automated data collection. We can start exploiting something called subsea technology. I'll describe that in a moment. Of course, safety is paramount. Environmental impact, worker impact, very big concern for the oil and gas area. On-site, collaborative operations, where we bring together the operational technology and the IT side of the house. I'll describe that as well. Remote operations, so we can remotely monitor offshore, but also other plants around the world. Collaborative operations, where increasingly we are integrating the capabilities of companies like ABB and those of its customers so that they work together as a team. Fleet management, where we can operate fleets of vessels, but also remote rigs, remote wells, manage them as a collection of distributed assets, and then increasingly integrate all these forms of infrastructure, the electrical, the controls, and various systems that I described in the previous slide. So this creates a portfolio of digital offerings where we can do everything from optimizing the wells, helping provide dashboards for the well operators, as well as other parts of the upstream operations. Energy management, now you might find it a little bit odd that an oil and gas infrastructure is concerned about energy efficiency, but it is in fact an increasing concern because some of these compressors and pumps are big consumers of electrical power. Digital projects, which is where we help design these projects digitally using cloud-based design technologies, digital twin simulations, and then also networked software-based systems that are very flexible in terms of their deployment to help accelerate time to deployment. And then, of course, above everything, safety of the workers, cybersecurity, physical security, all need to be considered. Supported by a framework that we call collaborative operations, and of course, connectivity and cyber. So one of the main opportunities to start is in connecting the unconnected. And while the new systems increasingly come with network connectivity, and I'm talking about drives, I'm talking about connected sensors, there's still, especially in this legacy infrastructure, a lot of moving parts, valves, motors, which are often the cause of outages and issues. And because they're unmonitored today, people can leave a valve open, set to the wrong setting, or a motor could start to misbehave, and we don't know that that's going to be an issue. 1 hour of downtime on a rig can cost these companies up to $1 million an hour. So unplanned maintenance, unplanned downtime is the enemy. And as this infrastructure ages, this becomes a problem. Earlier today, I heard one of the speakers talking about wireless and battery-operated sensors. And this is increasingly the norm. So we make sensors that sit on top of valves. Some of these operate on batteries. Some of them operate on energy harvesting technology, so they don't need batteries at all. We also make sensors that are able to fit on a motor. And that essentially monitors vibration and temperature and a few other parameters so that we can now detect early signs of wear and tear. And by monitoring these moving assets, we can enhance their life, make them more efficient, and of course, increase production. The other key trend is towards what I would call, in parentheses, more autonomous operation, because it's not like people are going to disappear, but especially with offshore rigs, for example. What's increasingly happening is that offshore rig, the oil platform that is quite iconic for this industry, is going to disappear. It's going to move below the surface of the sea, where we no longer have issues with storms, crews, and everything else that remains topside. And in fact, one of our customers has put the entire rig-based infrastructure on the bottom of the seabed, 3,000 meters below the surface of the sea, and about 48 kilometers away from shore. And what we have to do to support that is provide drives and motors and industrial PCs that can operate essentially at near freezing temperatures at incredible pressure levels. And of course, I don't have to explain how reliability and remote maintenance is important, because nobody wants to do a firmware update at 3,000 meters below sea level. And the second aspect is autonomous vessels. So for example, just like you're hearing about driverless cars, shipping is becoming more and more autonomous as well. And in 2020, in Norway, a ship called the Yare Birkeland is going to be setting sail, delivering goods between various ports in Norway, completely autonomously with no crew on board, using LiDAR and other sensor technologies. And those ships are increasingly electrified, and of course, everything is always cooler with robots. We're also considering the use of robots to help plug in the very large power cable when that ship docks to shore. But the second key opportunity is around integrating the IT and the OT side. So as much as upstream and downstream are siloed in oil and gas companies, there's also a divide between the IT side of the house and the operational technology side. And this leads to islands of automation. So we have these production systems, such as the enterprise resource planning, HR systems, very important for tracking where the workers are, for example, figuring out which worker should now next service or do some maintenance. And on the control side, or the operational technology side, we have distributed control systems or enterprise asset management systems which track the lifetime and predict the performance of assets. Clearly, these two worlds need to be combined. If we're scheduling proactive maintenance on a piece of equipment, we need to find the next available technician and optimize that service path. And what's exciting to see is with some of the new technologies, whether it's augmented reality, whether it's portable devices like tablets and mobile phones, there's the ability to fuse this data coming from the OT side and the IT side to create common dashboards and contextual awareness. One of the other big trends is towards standardizing on the downstream side the refinery process, these big plants. And for those of you that are not familiar with oil and gas, I want to show you by parallel what happened in the IT side. So it was only just about 15 years ago that large data centers on the IT side were built out of big mainframe computers. And this picture was taken of a Cray supercomputer, I think sometime in the 1980s. And that was the time of like big computers and bad suits. But I think what you then see today is that the data centers of today are built out of cheap and cheerful modules of standardized computing. And if you need more capacity, you just add more racks. That's how Google, Facebook, and all the modern data centers are built today. And that took place over about 15 years. So why am I telling you about IT when this should be about oil and gas? Well, because the same thing is happening in oil and gas. We have the mainframe model of oil and gas with a big refinery, big complex machine. And what we have pioneered in our research center in Germany is something called modular production. And literally, in something the size of a container, a shipping container, we pre-integrate a mini refinery. It has the drives, the motors, the control system, all of that system shrunk down to the size of a container. And by pre-integrating all of this, we reduce a lot of the complexity that occurs in building a traditional refinery because we're building it out of Lego blocks. And if you need more refinery capacity, add more containers. And what's powerful about this, although it doesn't immediately leap off the page, it's vastly more efficient. In terms of operating expenditure, you have standard replicable building blocks, typically reducing downtime because of the reduced complexity by 50%, reducing the energy consumption as well. These small systems can be very efficient. And then the logistics by 30%. But also on the CapEx side, it's cheaper to build it out of these modular blocks. The engineering work is reduced by half, commissioning time by half. And then the other is time to market. You can build something like this much more quickly because a lot of the complexity is reduced by pre-integrating this into a modular unit to begin with. And our friends at ARC Advisory estimate that in the near future, about a quarter of all new refineries will be built this way. And we've seen this happen in IT. It was just in a matter of years that all new data centers were built out of modular components, and we think it'll happen here too. But another key challenge that exists in the oil and gas industry is related to this aging of the workforce, but also the complexity of all this new machinery that's showing up. Of course, everything is increasingly computerized and software controlled, which leads to the following problem, which was explained to me by a customer when I went to visit them in Houston just 2 weeks ago. And this is thanks to them. They basically said, look, the time of maximum knowledge is when we receive that refinery or that plant or that rig at commissioning time. That's when we get trained, when all of our people know the most. Therefore, when a problem arises, we can fix it quickly. And what happens over time is the knowledge erodes. We lose the know-how, people retire, people leave, and therefore the knowledge of those systems declines, which also means the time to repair when something happens increases. And this isn't going to go away. As we saw, the demographics in this industry are against them. But the answer is to embrace something that we call collaborative operations, where the know-how and the expertise of the supplier doesn't stop at commissioning time, but it continues afterwards, during operation. And it could be everything from analytics, to operations, to monitoring the assets, to optimizations, cybersecurity and safety. And we provide this in a variety of ways. We can do this in a watch me mode, where we just observe and advise. Or we can do it with a let's do together mode, where experts from ABB and experts from the customer work together to solve problems. Or we can do it for them as a service, where we run some of this critical infrastructure to supplement that knowledge gap. And I think increasingly with the lower cost of connectivity, more of these devices being connectable from the get-go, we see a bright future for this kind of model. And it's also what our customers are asking for to address that knowledge gap that they see. Which now brings me to the implications on the IoT platform. Because what I'm describing, in some sense, is what people call the control loop. To sense and to analyze, you're taking the physical information, vibration, temperature, turning it into digital insights, analysis. But the real power is when you can automate and act. You're taking the digital back to the physical. And this control loop, we believe, will remain on-premise. health and safety requirements, data sensitivity, mission criticality. I'm a former networking person. I know all about latency. It's not a latency problem. The control loops will stay on-premise. But there's another loop, which we call the asset loop, where you're monitoring assets not in milliseconds, but you're monitoring them over hours and days and weeks and months. And you're looking for predictive maintenance. You're looking to find the optimal maintenance interval, for example. And that asset loop, we believe, is increasingly going to go to the cloud. Because in the cloud, we have a rich ecosystem of partners doing analytics, new startups, other companies, new technologies, machine learning, AI, and the rest that are cheap and plentiful in the cloud and that are easier to deploy there. The actuation loop of the asset loop, I sort of shaded in a lighter color because that's not necessarily being done through digital technology. It might be a technician replacing a component. But we see that in terms of the IoT stack, it's the device, the edge gateway, the hybrid cloud, and the cloud that all need to be pressed into service to provide these two loops that are happening. And I think this is a point of clarification that a lot of people get confused. They sort of commingle the control loop and the asset loop, and I think that's a mistake. So when we think about these various digital systems, they're going to get deployed on-premise, like we just described, the control loops, increasingly with a connection to the cloud for the asset loop. And lastly, one of the things we're also seeing is the interconnection of the clouds. And whereas some companies will say, look, there can only be one. I call this the Highlander fallacy, by the way. There can only be one platform, and everything has to move to my platform. We think this is nonsense. We think that in the world of today, when connecting one cloud to the other is a simple REST API call away, it doesn't matter where these systems reside. And an example of that is some of the work that we're doing, for example, with IBM Watson, which is available only as a cloud offering. And one of our businesses is sending data to Watson Cloud from our cloud, getting insights and predictions back, and acting on those insights. And the agility that gives us, because we can interconnect the clouds much more quickly than changing or updating all these on-premise systems, is the reason we believe that this intercloud model will prevail. So let me now switch to talking about several customer examples. And the first customer I want to describe is Norske Shell. And for many decades now, they have been deploying offshore rigs for natural gas. And in fact, in one of these cases, we supply about 20% of the gas going to the UK, for example. And these assets are now 30, 40 plus years old. And we've been able to extend the life of these assets by 20 years over their original planned lifetime. And that's by continuous monitoring of those assets, predictive maintenance models, understanding which parts of them to replace, scheduling the maintenance windows to minimize downtime. But another example of where we've been able to boost productivity is actually by something called choke control. So when you start up a well, if you start it up too quickly, you can get sand and gravel going into the well, which will ultimately destroy the well. And of course, if you take a long time to start a well, then you're missing productivity or output, which can be in the order of $100,000 to $300,000 per hour. So with a sensing and control automation loop, we've been able to optimize the optimal startup time for each of these wells, which has taken the startup time down from 9 hours, which was the very conservative startup, to 2 hours without any risk to the well or safety. The other optimizations we've been able to do concern energy. So typically we're compressing natural gas, which means we need pumps, and operating those things at a constant speed versus a variable speed using drives and motors together. Typically, a variable speed drive combined with a motor can pay for itself in about 2 years just from energy savings alone. It also extends the life of that motor by typically up to 30%. And thanks to this and a number of other improvements, including the deployment of a combined OT and IT system where we have a single integrated dashboard that fuses data from the control system side, but also from their IT systems into a common single panel, we've been able to help them achieve a doubling of their oil recovery, and this is now one of the highest recovery wells in Norway. The second example is what's called a floating production storage and offloading system. It's a massive system called Goliath. And this is operating at the Arctic Circle, all the way up near the North Pole. And using something called intelligent projects, we've been able to reduce the commissioning time of this project. So what is intelligent projects? This is about using cloud-based digital design teams so that various members of this project, whether it's ABB, customer, and other EPCs, for example, are able to more quickly design this project. And then also when it comes to the commissioning, by using more software-defined systems, something called Smart I/O, where you can essentially logically configure the connections as opposed to being tied to physical connections. You can repurpose the design, if you will, of the control system at the actual go live time as opposed to at design time. So all of this reduces complexity, the chance of errors, reduces the number of power distribution centers that we have to have, so reduced infrastructure requirements for that customer. We also invested in safety systems. So safety and environmental impact are now increasingly paramount for the oil and gas industry. And tracking of the people, the settings of various systems. So for example, one of the most common mistakes is when a piece of equipment is replaced due to maintenance, it's not set back to the proper operating settings. And that's something which, again, sensors, wireless connectivity, and also remote monitoring capabilities can help to detect. So this combination of systems has been able to dramatically improve their commissioning time and reduce their engineering complexity. And the third customer example is with TANAP oil and gas pipeline. So this is a 1,800 kilometer pipeline. And one of the main issues with pipelines is because they're very long and distributed, they go through a lot of areas where it's difficult to get to. Theft is a major issue. People can fill up a tanker of oil or gas in about 15 minutes by tapping into a pipeline. And globally, $37 billion are lost every year through theft from pipelines. So what we've done here is we've implemented fiber optic cables that go all along the pipeline, and by detecting vibrations, which could be because somebody's trying to tap into it, we can detect where that happens and then quickly try to observe it with either closed-circuit TV cameras or potentially in the future drone technologies. We also do this in terms of protecting the physical stations themselves. So every so often there's a pumping station and there's chain link fences around these stations, and we've woven fiber optics into the chain link fence, which can detect similarly vibrations on the fence itself, which then engages a closed-circuit TV system for physical security monitoring. But that's not enough. We also have to protect against cyber attack. And as we've seen in recent months, energy infrastructure is increasingly being targeted by nation states to bring down the electricity or energy grids of those countries. And here in particular, we've built what we call defense in depth, integrating various levels of security to protect the SCADA system, which includes a fully redundant operation, something called point of control. We can actually take control of this entire pipeline from a centralized place or move it to one of the multiple remote operation centers along the pipeline, so that should one of those facilities be compromised, we can shift instantaneously the operation of the pipeline to another location. So in summary, I've given you several examples of where connecting the unconnected, integrating IT and OT, moving to more autonomous operations, helping to combine the physical and the cyber using smart collaborative operations, remote management to supplement the knowledge gap. These are just some of the levers that we can pull on to boost overall productivity. And if we now map that across that upstream to downstream cycle, we believe that we can go from being reactive, when issues arise, we fix them. With predictive, proactive maintenance, we can prevent much of that. We can boost the oil recovery rate through this automation at the wellhead, for example. We can speed up the well startup time, as we saw in the example from Shell. We can also improve the yield of those wells thanks to the improved sensitivity of eliminating the sand and sludge and other waste products. Cutting the planned maintenance windows through intelligent scheduling, because now we're doing predictive maintenance rather than reactive maintenance. We also eliminate much more of that unplanned downtime, as we saw. That could be a major cost. We also minimize the amount of lost production, restore time to service, especially with collaborative operations, where experts from our company working closely with customers can help restore service much more quickly, and overall improve the on-time delivery thanks to capabilities like modular production. And so, in closing, there's a huge number of these digital projects or solutions that are relevant to oil and gas. And the time is now because of the urgency, thanks to the foreseeable future low price of oil, so productivity is paramount. And we also know that with the other aspects such as cybersecurity, demographics, and aging infrastructure, the time to act is now. And we've seen this not just in oil and gas, but across a wide range of industries. And this is why I invite all of you to come and visit our booth just across the hall here and talk to us about some of the solutions we can provide for you. Thank you very much.